So hi guys, today we have another problem, that is partitions with given difference. Basically, you are given an array and you have to divide it into two subsets and make the difference of it and check if it is equal to D or not. You have to still check all the possible ways to partition into two different subsets and make the difference of those subsets equal to D. And you have to keep remind of one thing, that one subset will be greater than equal to another. Basically, if you name one subset S1, basically the sum of the subset, it is S1. If it is greater than equal to S2, and then also you can check if the difference between S1 and S2 is equal to D or not. So this is the question, and let us take an example, this one, and you can see that they have partitioned it between 2 and 6, and one set is 6 plus 4, that is 10. Another set is 5 and 2, that is 7. So 10 minus 7, that will be equal to value of D. So there is one possible way. So this is the question that we are asked for. So basically, what can we do? One thing is sure, that we have to generate all the possible subsets, right? So how can we generate all the possible subsets to check if it is matching to our condition or not? So there is only one way, that is regression, take non-take approach. And I have already drawn the take non-take approach here with 5, 2, 6, and 4. You can clearly see that in the left hand side I have taken it and sum it up, and in the right hand side did not take anything, right? So after the all the possible combinations, the diff node, that the containing answer, basically you can clearly see that all the lib nodes are contained the answer, and not answer, basically the sum of the say subsets, all possible subsets. And you can clearly see that what I have discussed, they have partitioned it from here. So one partition is, one set is this one, another set is this one. So if you consider this set, then let us try to trace here. Basically, I have taken 5 here and 2 here, make it 7, and I didn't take anything. So the sum will be 7, and also the total sum of this superset, that is 17. So if I reduce from this sum to this element, then it will be 10, right? And one thing is sure, that if we are if we are taking this element, then we can reduce from the sum, and the reduced sum, that is 10 here, and the current sum that we are making to make this recursion tree, that is 7. If we make a division, sorry, a subtraction between 10 and 7, then the answer will be 3, and it will be equal to the value of D, right? So this is a possible way to get our answer. Whenever this condition satisfies, we will simply return 1, otherwise simply return 0. So this can be one of the ways. So actually I have tried to submit this way using DP. So this was actually getting TLE. Why TLE? Because you have to declare a lot of space, the sum plus 1, that will be huge, and also n. So it will be a huge space that they are not mentioning for us. Or so what can we do? We have to somehow reduce the extra space. Okay. The time complexity will be same. There is nothing to do. So we have to somehow reduce the space. You can clearly see that in question they have mentioned that S1 should be greater than equal to S2. So can we make some equation to reduce the space? Yes, I can. Observe this thing. So we know that S1 plus S2, it will be equal to some, right? And another thing, S1 minus S2 it will be equal to D, right? Yes, both two conditions are right. So let us sum it up. So 2s1, it will be cut, and it will be sum, sorry, sum plus D, right? So observe one thing. This S1, the value of S1, it will also be an even number. It will be always an even number because we are multiplying into 2, right? So there is one base case, that is if the S1 is odd, then we have to return 0. There is no other options. We cannot divide the 2 into the two subsets. So one thing is clear. Another thing, as I said, that we have to reduce the size of the sum. So S1 is equal to sum plus D by 2. Okay. So now this will be the size of the DP. Means here I have taken the sum here, but now we have to take S1 here. So it will be reduced a lot, right? So this will be our approach, that we have to calculate first of all the value of the S1, and then we have to make the DP array. And then we have to modify the take non-take approach. Basically, then our target will be to reduce S1 to 0. If it is equal to 0, then you can return 1. Otherwise, we can return 0. So basically, if we use the take non-take approach and make all the possible subsets, and the sum of the subsets, if that can reduce the S1 to 0, properly 0, then we can also you can return uh, 1. If all the subsets that cannot make the sum to 0, sorry, S1 to 0, then we cannot return 1. So this will be the new approach that we are going to have. So basically, let us calculate for the S1. That will be what I have said here. That is sum plus D by 2. And okay, we have to calculate sum also. In sum, sorry, will be 0 for in type is less than plus first, and here are, sorry, I. So now we have the sum, and let us calculate for the S1. That will be sum plus T, as I have said here. So if the value of the S1 is even, then we can continue. Otherwise, we cannot. So return 0. And then S1 will be updated by S1 by 2. Why S1 by 2? Because for this part. Okay. So now let us declare the DP vector. That will be N, and here vector in, it will be S1 plus 1. Why plus 1? First, we will start from 0 to S1. So we need extra one space, and minus 1 obviously. And let us return solve. That will be array S1 and D also, and DP. Okay. Let us try to write the function solve. Will return int solve, sorry, vector int error int target. Let us name it target. in D and vector dp. Okay, so let us come for the base case later. Let us try to write the take non-take approach at first. Int non-take. Non-take will be simple. Solve ARR. Target will be as it is. B. I- Okay, I have missed one another thing. That is actually we do not need D here. Sorry, because we have to make the S1 0. It will be n minus 1. Okay, and let us name it IDX. So IDX will be reduced by 1. Obviously, we are not considering that element. So DP and okay. So now let us check for the take part. So take will be initially 0 if take is sorry not take target if it is greater than equal to ARR of IDX, then also only we can apply the take part, the call, the function call for take. Solve ARR. Target will be reduced by ARR of IDX. It will be IDX minus 1. Obviously, we are considering that element. So DP and actually why I have done this thing basically we have to check for the base case that if the error of IDX is greater than the value of the target, then it will go for the negative value, right? And we cannot consider negative value here. So now let us return dp of that is IDX. Here it is target is equal to take plus non-take. Now let us come back and write the base case. So what can be the base case? If target is less than 0, obviously it cannot happen because we are using this one. But for safety purpose, we can use this. It's no problem. So return 0. And if IDX is less than 0, basically we have completed all the elements. And now if the target is 0, then we can return 1. And otherwise we can return 0. And also you have to check for the DP array if that answer contains into the DP. So DP that is IDX and target not if is equal to minus 1, then we have to return DP IDX and target. And in the question they also states that we have to modulate by 10 to the power 9 plus 7 because the number will be huge. So in mod it will be 1E9 plus 7 and just apply mod here also, here also. And after that, let us mod it here. So let us try to run the code. Fully everything is right. Okay, so we have another error that is sorry, I have missed something. Yeah, now it is perfect. So the answer is matching. Let us take another example, the given example, and it is running fine also. Let us try to submit the code. So perfect, it is working. So for the time complexity, it will be polynomial almost n into the sum of the array and the extra space that we are taking, that is the value of s1 into n, the size of the array. So this is the approach to solve this question. And obviously, this is a good question basically because you have to make the efficient algorithm to make the size of the DP. So yeah, hopefully that thing is clear to you. So bye. See you in the next video.